Hey everyone, in this video we'll be getting pretty hands-on. We'll specifically be talking about deploying ML and large language models from HuggingFace onto SageMaker Real-Time Inference. Before we can get into that topic and kind of the hands-on code lecture itself, what we'll do is give some context around ML model deployment, what exactly we're looking at, what is model deployment, what is HuggingFace, and how does SageMaker exactly help with the deployment process, just to give you all some more context before getting started. So the first question I wanted to tackle, right, and I've given a bit of an overview here, is what is ML model deployment for those of you that are not familiar? It's essentially the practice of exposing, right, a ML model via REST API. So once you've trained your model often, that trained model has a set of artifacts or its updated weights post-training, it reflecting in terms of like what it's learned, what its model weights look like after the training loop. Those model weights we need to be able to expose via REST API to actually serve requests or inference. Because basically if we don't deploy the model, we're never really able to understand how exactly we can interface or work with the machine learning model itself. So that art is known as ML model deployment or hosting or inference. All the terms are a little interchangeable, but just think of it as you're exposing your trained ML model for inference to be able to handle requests, process any traffic, and actually kind of like give you an output back. And the reason, so these model weights, right, this is what we're deploying itself. And the reason for these model weights, cloud providers are so important is, you can imagine these model weights are not tiny, especially when it comes to LLMs such as Llama and more. We're thinking of multiple gigabytes worth, and loading this up locally is a very, very difficult task. You might be able to do it with more of the traditional ML models. So let's say if you have a scikit-learn model or a smaller PyTorch model. These are smaller machine learning frameworks, smaller model architectures, and they might not be as heavy computationally, and you can serve that on your local machine. But as you scale the model size and you need the requirement, right, for more compute store to basically be able to handle these types of weights and things of that sort, that's where cloud providers become really handy in terms of AWS, GCP, Azure, and basically any managed services that provide a simple way of working and storing these model weights and serving them for inference, essentially, for an API. The second question, right, before we even get to AWS here is, what is HuggingFace? And where does it come into play here? This is the second question. So these model weights that we're talking about, oftentimes you can build your own machine learning models, and you can have your own artifacts, you might be able to have your own training loop. But there needs to be a bit of a community. For those of us that are not data science builders, so I'm personally an ML engineer, I don't know much about model building itself. For those of us that might want to access certain pre-trained models and just take their weights and deploy it, let's say we're happy with that model and the way it's performing for inference and it fits our use case, what we're going to do then is we can grab these pre-trained models from a provider such as HuggingFace, basically. And what HuggingFace provides is a extensive model zoo with different models across different like modalities and use cases that you can essentially pull down from. And what we'll see often in HuggingFace in this model zoo is there's a lot of LLMs that are open source, so they share their model weights basically. And these include things such as Llama. We'll work with Flam today, but all these model weights are exposed in a public basic repository essentially for you, where you can easily access these LLMs. And this is one of the many reasons HuggingFace is so popular and important for ML engineers to learn, because you can almost think of it as a OSS kind of safe hub for accessing these different models. And these are all available via their APIs, but more importantly, HuggingFace also directly integrates with different cloud providers and services such as SageMaker. So there's also that cloud integration with the models that are accessible here natively. So we can directly work with them and we can port them over for both training and inference depending on the provider and whatever feature support there is. I do want to call out that HuggingFace is a lot more than just the model zoo. There's a lot of different HuggingFace APIs that simplify model training, building, along with deployment, right? So it's not just one kind of scope there. You're basically getting, the library is known as transformers, and I'll share that resource down below basically. But you can really simplify a lot of these different processes such as model building, model training, and model deployment from other frameworks and libraries. So traditionally in PyTorch, right, that loop might take a lot longer training using a framework such as PyTorch. But when you use HuggingFace-based APIs and tools, you're basically able to simplify these processes through their higher level APIs. And most importantly, at least for our use case here, right, is we have this Model Zoo where all these different models will be accessible for us. And the third part and the final piece for the puzzle, I don't know why I put all this out of order for you guys, but right here, if we see the third and final part of this puzzle is our deployment option. So there's different ways you can deploy these models, right? You need the hardware, as we said, some compute that will be able to host this model. But we also need the environment, which can essentially allow us to serve these models and load them up, essentially. And that's where SageMaker Real-Time Inference comes. This is a feature known as SageMaker Real-Time Endpoints, where basically you can select one, the compute. So right here, this green box right here, you can select the hardware that you want behind it. You can say CPU or GPU. You can point towards your model data. In this case, we'll simply point towards the HuggingFace model artifacts directly. And we can say these are our model weights that we're trying to essentially deploy for inference. And number three, that runtime environment I was talking about, that model container basically is going to say, hey, if you have a PyTorch-based model, this is the runtime environment I need. If you have a TensorFlow-based model, this is the runtime environment I need. And if you have a LLM, such as the one we'll be deploying in this use case, I'll essentially provide a container that gives me the runtime environment. And I'll link my containers video down below for how they work with SageMaker. But essentially think of this as it's preparing the environment to execute this model. So while the real kind of compute power comes from the hardware, the protocol for taking those model weights, loading them in and out of memory for that hardware, handling the requests that are coming in, all that protocol is taken care of by the model serving engine, which is fronted by that model container essentially. So you need that model container to kind of work with your server-side kind of logic there essentially. And these three pieces together create a real-time endpoint on SageMaker Inference. And right here, right, this might seem complicated, and that's where we'll go deeper into SageMaker Inference in a different series. But what you mainly need to understand is that you have a user, you're going to send a REST API request, basically, and it will hit that persistent REST endpoint that we have. And underlying what's happening is that container is processing those requests. It's working depending on the compute that you have in terms of processing and handling those and returning them to you in a latency and throughput sensitive type of use case. And that's something really important to remember about real-time inference. This deployment option is meant for latency and throughput, horrible handwriting there, apologies, sensitive workloads. So if you're trying to get a request instantaneously, this is the deployment option that you're trying to work with. We'll go into different deployment options available within SageMaker later, but if you're trying to have real-time workloads, basically, this is the type of option you want to work with. Three constructs just to get familiar with before working with SageMaker Inference. We won't dive into them because we're going to use a higher level API here, which abstracts out these constructs, but it's important to know these, and we'll talk about them more in later videos. But if we see here a SageMaker model object, right, this is essentially your model data plus container. Simple as that. So you're going to say my runtime environment, and then this is my model weights. And for us, both of this is going to be taken care of actually and abstracted out via the HuggingFace integration with the SageMaker Python SDK. In this endpoint configuration, this is once again also abstracted out in this use case. We essentially specify our hardware and any production variants. So SageMaker is a managed service for deployment as well and across the ML lifecycle. And what I mean by variants is if you have any different production variants, if you're doing any type of shadow testing, kind of any A/B testing that you might be working with, you can configure that within this endpoint configuration. And this SageMaker endpoint, which is kind of the final chain here in this list of objects that we have, is our REST endpoint, and this is what we'll actually be invoking. And I'll show you exactly how that HTTP URL looks like in a second, and the code example itself. But what I want you to take away from here, right, is all these pieces fit in together. So model deployment is the action of serving a model and making it available for inference, where you could actually send in requests, get an output back from your model, and HuggingFace specifically where it assists is if you're not a data scientist especially, and you just need an open source model that's maybe already been trained, and you just want to take those model weights and deploy it, it gives you an OSS easily accessible way of looking at it, and it integrates with different deployment options or providers such as Amazon SageMaker. And Amazon SageMaker has features such as real-time inference, where you can essentially take that model data provided by HuggingFace. You can essentially take this container, which we'll notice is auto-provided by HuggingFace, and select the necessary hardware that you need behind your REST endpoint that you're going to be invoking. So with that being said, let me get right into the code itself so we can dive into this. Right here, I'm within the AWS UI right here, and I've come to SageMaker AI. They've renamed this to SageMaker AI recently. SageMaker Platform is the one where Unified Studio is available in preview at the moment. But here in SageMaker AI, right, we're going to need an AWS account as prerequisite here, obviously. And we'll be spending a little. I'll talk about all the resources we're using here in a second. But what we'll specifically do is we'll hop into SageMaker Studio. I've created a default domain here. This is basically an IDE for ML development. You don't need to use it for deployment. You can use it whatever way you want. If we go in here, we'll see that I've opened up a Jupyter Lab space right here, test space. You can basically select the space, select the compute that you want to execute the space on. So this is compute that's available for the notebooks that you're going to be working with in there. I just selected a C5 large, added some extra storage just because. This will start up pretty quickly if you create a space right here, essentially. So keep in mind, when you have this running, you're going to get billed for this compute as well. I've learned the hard way there. And here, if we get into this Jupyter Lab environment, once you've created and have that space running, we can focus on the deployment specifically. And what's super neat is I've actually not written any of this code myself. It's all the auto-generated code by HuggingFace itself, and we'll go into HuggingFace in a second. But the idea behind this notebook is what we'll do is we'll take a sample LLM, Flan T5 base, in this use case, and show how you can deploy it on SageMaker Real-Time Endpoints, and show why it's so simple to work with HuggingFace and integrate it with SageMaker Inference, essentially. Now, before we can do that, I wanted to hop into the HuggingFace library itself. This is just my profile here, but let's go to models here, essentially. And if we see within models, right, it's super neat. We see all these different models are accessible for us across different modalities, different use cases. And you can essentially pick depending on what you want to work with. So you can sort kind of by popular. You can sort if you have a specific model that you're looking for. And what you'll see that's super cool is, and I'll go to Flan since that's the one we're using today. You'll see here in files and versions that all these model weights are publicly accessible for us. So this is what I mean by open source, when the contributors are essentially exposing these model weights. And when we come here, we can see information about the model too. How is this, depending on what the provider did want to expose. Here we can see just basically how you can use this model, what languages it has support for, different types of things, such as any research that was conducted in the building. That's where the real geniuses are at, in my opinion, people designing these crazy models. And you can see how you can run this using HuggingFace specific libraries. And then more importantly, for our use case, let's say you want to train or deploy this model. Because deployment, as I said, is really where ML inference or ML use cases are realized. What uses a model if you can't invoke it or work with it? And you'll see here, it's automatically works and integrates with different providers. Now, this might not exist across all HuggingFace models. That depends on the model, and you're going to have to check that. But in our case, our deployment option we want to use is Amazon SageMaker. And if we see here, there's some boilerplate code that I already grabbed, basically, that I can use. And this code directly ties in the SageMaker Python SDK with HuggingFace. And as you can assume by the name, SageMaker Python SDK is a bit of a higher level SDK provided by AWS, where you can interact with deploying and training models. Don't get it too mixed up with Boto 3. That's the low-level AWS Python SDK. You can also use that to interact with SageMaker. But often examples you'll see are using this one right here, because as you can see, it has utilities to work with HuggingFace. It has many different abstractions, and it's a bit of a wrapper around the lower-level SDK that we were working with there. So if I come back here, the two notes that you want to think of, right, that we're abstracting out, if you remember from our diagram, is that we're abstracting out the container selection. We're not telling you that you have to choose a container. We're going to default provide it. HuggingFace is going to say this is the ideal container or model serving engine that you should use for this specific model that we're recommending. The version and everything will be chosen for you. Traditionally, you'd have to pick the container yourself for whatever real-time endpoint you're deploying. So if you don't have that knowledge and you want to just take the default container and choose it, that's a very neat feature that happens here. And the second thing HuggingFace does is it automatically selects the minimum compute instance that you need behind the endpoint. So for large language models, oftentimes you need a machine with a certain amount of GPUs or a certain amount of compute. And the neat thing HuggingFace has done here is it's auto-selected basically the compute that you need at minimum to work with this model. Now, neither of these are hard configurations. You can tune and adjust them if you have the knowledge or if you have the flexibility and want to test different kind of configurations. But what we'll do is we'll stick to the defaults here. If you uncomment this cell, basically, this upgrades SageMaker to the latest version, so you have access to the latest API calls. Here, basically, I'm getting my SageMaker execution role, which will let me work with the SDK, basically, to create a SageMaker endpoint. And the next thing I do is very, very neat and simple. I'm going to provide a hub dictionary object here, and all I'm saying is the HF model ID. And this is how HuggingFace and SageMaker knows where to pull the model data from. So when I specify this key here, you'll notice that this key is specified right here. This is the model ID that I'm working with. That's base, but if you see here, yeah, we are using base, sorry. So if you copy this, right, you can replace this with whatever other model you're working with. So if I go back to this models tab, in this case, for Llama 3, I would copy that and I would substitute that here for this model ID essentially. And what's happening is we're specifying that and we're saying pull down the model weights in this public repository here essentially. Pull down whatever weights are here for us to be able to work with. And then the second feature that was auto-populated for us by HuggingFace is the number of GPUs were essentially specified already. And what's happening here is we're going to split this large language model, don't worry too much about the theory, using tensor parallel across 4 separate GPUs because these LLMs often cannot fit into a single GPU. So what we do is we shard the model here essentially. And this is once again auto-populated by HuggingFace because it understands the optimal configuration here. Next, we specify a HuggingFace model object. This is once again specific to SageMaker, and if you remember, I specified 2 things, a SageMaker model and SageMaker endpoint config. And what we're doing here is this HuggingFace model, it kind of wraps around that construct because it's a higher level API call by the SageMaker Python SDK. It automatically selects the ideal container to deploy this model, which is a HuggingFace container in this case. And like I said, there's available images MD that you can work with. I'll link that below as well. That shows all the containers that are supported by SageMaker DLCs essentially. In our environment variable, we specify this hub, which is pointing towards the model that we're working with essentially, and our role to be able to work with it. We can then deploy this into a persistent SageMaker REST endpoint, and we see that the default instance type is selected for us, which is a G512X large in this case, and that has 4 GPUs available for you to work with. This takes a few minutes to run, so I already ran this. But in the meantime, what we can look at, right, if we go back to this UI, and we see here in inference, we see we have SageMaker model objects. That's that model object that I already created by default. This happened underneath the hood when I clicked deploy to create that SageMaker endpoint. And there's also an endpoint configuration that was created for us. And then this endpoint was the final kind of chain, final kind of step in that chain or process right there. When I hit this .deploy, basically, rather than having to make 3 API calls with the lower level Boto 3 SDK, the SageMaker Python SDK, since it has tightly coupled integration with HuggingFace here, we can simply specify, right, that model ID, specify, right, our container, which is auto-selected once again, select the hardware, and this will deploy and create these different persistent REST objects for us. So traditionally, you might have to define these your own, and you can use and we'll cover this once again, I keep saying it in another video, but we'll get to this. You can use the lower level Boto 3 Python SDK to have the granularity, where you can specify the create model API call, create EPC API call, create endpoint API call. But to make life easier, that was the point of the SageMaker Python SDK, where you don't have to manually create each and every single one of these objects and feed them into each other. So what happens here is we deploy that. Those objects are auto-created for us, and the most important object is this endpoint. And if you see right here, you can see, as I was saying, there's a public REST API that you have here, and you don't want to expose this. I'm going to be deleting this after. But generally, if you want to encrypt this via VPC with private link as well, you can do that. But we have this public REST endpoint that we can essentially invoke. You can think of this as any other REST API that you might be working with. And this dash invocations path is what's being exposed in the backend. So once it's deployed, I can then send in a sample request, and we see that it's generating an output. And with SageMaker Inference, the nice part is, right, with this real-time endpoint, you have a summary of everything you're working with here. So if I see here in monitor, you can see the utilization metrics basically for what exactly is happening with the instance or the host that you're working with. You can also see our invocation metrics. So if I do sum here, sorry, I think I toggled that out by accident. If I do sum here, Let's do the last hour, and we'll see the invocations that I've sent. I just sent one request right now, so you'll be able to see that getting populated over time, and any errors you have, you can check in these model container logs. So that at a high level was how you could deploy. And once again, sorry, before I get to the ending right here, make sure you delete this endpoint. You don't want to incur any further costs, especially because this is a GPU instance, so you'll get billed a little more for that. I'll link the SageMaker pricing page so you're aware of what each instance gets billed in the hourly. But make sure to delete this so that you're no longer dealing with it there, because it'll get billed by the hourly essentially if you're not working with it. So have that there. I'll also add the delete model API call right here essentially. But yeah, this was a high-level introduction to how you could work with HuggingFace to really quickly deploy onto a SageMaker and real-time endpoint. I think this took maybe like less than 25 lines of code, and all of it was pre-populated. Sometimes you might have to patch it up or fix it if there's some error that you might be working with. But yeah, for the most part, HuggingFace, a very built-in model zoo where you can access so many different models, get easily started, and not really need to have much data science knowledge, right? If you just want to build a generative AI application and you want to be able to take a machine learning model and you know your use case, filter by the different use cases that are available here, pick the right model, pick the provider of your choice. In this case, we use SageMaker Inference, and then deploy it. And then you can work with it directly and integrate it into your generative AI applications. And like I said, there's a lot more coming in terms of SageMaker Real-Time Inference itself. I know we walked a little into what exactly it is, how it works, but we'll talk about all the different deployment modes, how you can essentially understand even at a lower level how it works. And yeah, any questions and feedback, as always, please feel free to leave in the comments and reach out directly to me on LinkedIn, Twitter, wherever you want to connect, just to follow up and have any one-on-one questions as well. Thank you as always for watching. It would mean a lot if you could leave a like and subscribe, and any requests in terms of whatever you'd like to see in the future as well. Thank you so much.